0 to 1.58 Mint 26 prompt. At this very moment, beneath the deep blue waters of the Mediterranean Sea, a concealed volcano is steadily expanding. After 4 centuries of silence, it is showing signs of awakening. Only 4 miles away from Santorini, one of the most visited islands in the world, scientists have uncovered a disturbing discovery. A vast magma chamber that has been forming for nearly 400 years. It contains enough molten rock to fill 500,000 Olympic-sized swimming pools, and it continues to grow year after year without pause. In January 2025, the Earth began to tremble. More than 30,000 earthquakes struck within just 30 days. Authorities in Greece declared a national emergency. Schools were closed. Over 11,000 residents evacuated the island. But what truly alarmed scientists came next. When researchers examined what lies beneath the surface, they found that Santorini and this hidden volcano are not separate systems at all. They are linked, moving together, breathing together, drawing from the same deep magma reservoir. Around 20,000 people live on the island permanently. Each year, between 3 and 12 million tourists visit. And beneath them, a volcano is slowly recharging itself for a future eruption that could rival the catastrophe that once destroyed an entire civilization. Is Santorini resting on a geological time bomb? Or has the countdown already started? When most people imagine a volcano, they picture a towering mountain erupting with lava, fire, and ash visible from miles away. But the most dangerous volcanoes on Earth are often the ones hidden from sight. They remain beneath the ocean's surface, silently building pressure and darkness, far from human view. And there are many more of them underwater than on land. Kolumbo is one of these unseen giants. It lies about 4 miles northeast of Santorini, submerged nearly 1,600 feet below the surface of the Mediterranean Sea.
No smoke, no visible crater, no warning signs that tourists sipping wine on the caldera cliffs would ever notice. Just blue water, hiding a geological nightmare. The location is not random. Kolumbo lies along the Hellenic volcanic arc, one of the most geologically active regions in the Mediterranean. This is the same zone that produced the catastrophic Thera eruption around 1600 BCE. The same eruption that generated tsunamis across the eastern Mediterranean and practically erased the Minoan civilization from history. And Kolumbo is not alone. It is part of a volcanic field containing at least 25 submarine cones, all aligned in a chain stretching northeast from Santorini. An underwater mountain range of potential destruction that most people have never heard of. The geological mechanics driving this system are relentless. The African tectonic plate is diving beneath the Aegean plate at a rate of approximately 1 inch per year. As the African plate descends into the Earth's mantle, it melts. That molten rock rises toward the surface, accumulating in chambers beneath the seafloor. The process never stops. The pressure never releases. The magma keeps building. For years, scientists studying this region faced a fundamental problem. They knew magma was accumulating beneath Kolumbo. Seismic data confirmed volcanic activity, but they could not see how much. Traditional monitoring methods failed to penetrate the seafloor with enough precision. The question haunted researchers across multiple institutions. How much magma is down there? How big has this hidden chamber become? The answer would take revolutionary technology to uncover. And when scientists finally saw what was beneath Kolumbo, the data exceeded their worst projections. The Mediterranean has a long memory of volcanic catastrophe, and the region surrounding Santorini holds some of the darkest chapters in that history. Around 1600 BCE, the volcano known as Thera erupted with almost unimaginable force. Scientists estimate the explosion released energy equivalent to hundreds of nuclear bombs detonating simultaneously. The eruption column punched into the stratosphere. Tsunamis radiated across the eastern Mediterranean, devastating coastal settlements for hundreds of miles. Ash buried entire cities. The Minoan civilization, one of the most advanced cultures of the ancient world, never recovered. Their palaces crumbled. Their trading networks collapsed. Within generations, a civilization that had thrived for centuries practically vanished from history. One eruption rewrote the future of an entire region. That was the power contained in this volcanic system. And Kolumbo sits in the same geological zone, fed by the same tectonic forces, building pressure through the same mechanisms. The last time Kolumbo erupted was 1650 CE. The historical records from that event are chilling. Pyroclastic flows, superheated currents of gas and rock traveling at hurricane speeds, crossed the sea surface and reached the shores of Santorini. Toxic gases spread across the island. 70 people lost their lives. For that era, with a much smaller population, the death toll represented a devastating blow to the community. Since that eruption, nearly 400 years have passed. Kolumbo has remained silent. No explosions, no pyroclastic flows, no visible activity disturbing the Mediterranean waters above its crater. But volcanic silence is deceptive. It does not mean safety. It does not mean the system has gone dormant. In many cases, silence means exactly the opposite. It means pressure is accumulating, magma is rising, energy is building in chambers that human eyes cannot reach. Scientists studying Kolumbo understood this principle. They suspected that beneath the quiet seafloor, something was growing, something potentially massive. But suspicion is not data. They needed to see inside the volcano itself. That breakthrough would not come until 2022. And what researchers discovered changed everything. In October 2022, a study published in the journal Geochemistry, Geophysics, Geosystems delivered findings that sent shockwaves through the volcanology community. A research team led by Kajetan Krapkowicz, a geophysicist at Imperial College London, had finally seen inside Kolumbo. And what they found exceeded every expectation. The breakthrough came from a cutting-edge technology called full waveform inversion. Traditional seismic monitoring could detect that volcanic activity existed beneath Kolumbo, but it could not produce detailed images of the magma chamber itself. Full waveform inversion changed that completely. The technique works like a medical ultrasound, but applied to volcanoes. Researchers aboard a vessel fire powerful sound waves toward the ocean floor. Those waves travel through the rock beneath the seafloor. When they pass through solid material, they move fast. But when they encounter molten magma, the speed drops dramatically. By measuring these speed differences across thousands of data points, scientists can construct a detailed three-dimensional image of what lies beneath the surface.
Scientists used advanced imaging technology that works like an X-ray of the Earth's interior. What appeared beneath Kolumbo volcano shocked researchers. The scan revealed a magma chamber no one previously knew existed. The chamber stretches from roughly 1.25 miles to 2.5 miles below sea level. A vertical zone 2 to 4 kilometers deep where molten rock has been collecting for centuries. Its width is about 2,000 feet, nearly 600 meters across. By volcanic standards, the structure is enormous. But size alone was not what concerned scientists. Magma chambers exist beneath many volcanoes around the world. What truly alarmed researchers was the volume of magma stored inside this chamber, and the speed at which that volume continues to increase. The calculations made by the research team exceeded all initial expectations. This was not a slow accumulation formed gradually over centuries. This was a system rapidly charging itself. A volcanic reservoir filling with molten rock year after year, decade after decade, completely hidden from human observation. The findings demanded urgent attention. And when scientists determined the total amount of magma contained inside Kolumbo, the implications became deeply unsettling. The chamber holds approximately 1.4 cubic kilometers of magma, nearly 1/3 of a cubic mile of molten rock. The number may sound abstract until it is translated into something familiar. That volume is enough to fill more than 500,000 Olympic-sized swimming pools, not with water, but with molten rock heated beyond 1,800 degrees Fahrenheit, or over 1,000 degrees Celsius, hot enough to instantly vaporize anything it touches.
But the volume alone is not what keeps volcanologists awake at night. The truly alarming metric is the rate of growth. According to the 2022 study, Kolumbo's magma chamber has been expanding at an average rate of 141 million cubic feet per year since the last eruption in 1650. That is 4 million cubic meters annually. Every single year for nearly 4 centuries, without interruption, without release. The pressure simply keeps building. Krapkowicz himself explained the implications. If this growth rate continues, within the next 150 years, Kolumbo could reach 2 cubic kilometers of accumulated magma. That number carries a specific and terrifying significance. 2 cubic kilometers is exactly the estimated volume expelled during the 1650 eruption. The same eruption that sent pyroclastic flows across the sea surface and killed 70 people on Santorini. In other words, the volcano is recharging itself, preparing for something comparable to what happened 400 years ago. The research team emphasized that this system displays characteristics indicating a highly explosive eruption. They compared its potential style to the Hunga eruption of 2022. That Pacific explosion generated tsunami waves reaching 66 feet in height. The eruptive column punched into the stratosphere, visible from space. Now consider the geography. Kolumbo sits just 4 miles from Santorini. The island hosts 20,000 permanent residents. Every year, 3.5 million tourists visit those famous white cliffs and stunning sunsets. A volcano recharging for a catastrophic eruption. Millions of people within immediate range, and a magma chamber that grows by 141 million cubic feet every year without stopping. The clock beneath the Mediterranean keeps ticking. On January 27, 2025, seismic monitoring stations began recording unusual activity approximately 6 miles northeast of Santorini, directly above the Kolumbo volcanic field. What started as scattered tremors quickly escalated into something unprecedented. Over the following 30 days, more than 30,000 earthquakes shook the region between Santorini and the neighboring island of Amorgos. The University of Athens reported staggering numbers. Over 15,000 quakes recorded in just 15 days. Nothing of this intensity had ever been documented in this region. The largest tremor reached magnitude 5.2 on the moment magnitude scale. Strong enough to crack walls. Strong enough to send objects crashing from shelves. Strong enough to remind every resident on Santorini exactly what lies beneath their feet. The Greek government responded with emergency measures. On February 6, 2025, officials declared a state of emergency covering Santorini. The declaration remained in effect until March 3rd. Schools shut down immediately. Classes suspended indefinitely as authorities assessed structural safety across the island. Officials issued an unusual warning to residents. Drain your swimming pools. The reasoning was grimly practical. Water sloshing during repeated earthquakes could destabilize building foundations. The constant tremors made even standing water a potential hazard. Approximately 11,000 people made the decision to leave. Some evacuated to the Greek mainland. Others relocated to nearby islands outside the immediate danger zone. Families packed essential belongings, uncertain when they might return. Uncertain what they might return to. Tourism bookings evaporated overnight. Hotels reported mass cancellations. An island economy built on visitors watching sunsets over the caldera suddenly faced the possibility that the caldera itself was awakening. The question on everyone's mind was immediate and terrifying. Was Kolumbo erupting? Were the 30,000 earthquakes the precursor to something catastrophic? Scientists scrambled to analyze the seismic data flooding in from monitoring stations. They needed answers. The residents of Santorini needed answers. In November 2025, a study published in Nature finally provided an explanation. And what researchers discovered was more alarming than anyone anticipated.
A study released in November 2025 in Nature revealed findings that reshaped scientific understanding of volcanic danger in this region. The conclusion was both precise and deeply unsettling. Santorini and Kolumbo volcano are not independent volcanic systems. They are physically connected, supplied by the same massive magmatic reservoir located miles beneath the Mediterranean seafloor. For decades, scientists treated these volcanoes as separate hazards. Separate risk evaluations, separate monitoring strategies, and separate evacuation planning. The new research overturned that assumption completely. The research team examined more than 25,000 earthquakes from the 2025 seismic swarm using artificial intelligence. The AI analyzed seismic signals at speeds beyond human capability, detecting patterns that conventional analysis could not identify. What the data revealed was impossible to ignore.
Beginning in mid-2024, the Santorini caldera started inflating gradually. Magma was pushing upward beneath the famous tourist destination. But the source of that magma was not directly beneath Santorini itself. The inflation preceded the intrusion of a magma-filled dike originating from a mid-crustal reservoir beneath Kolumbo. Sheets of molten rock had sliced through the Earth's crust at depths exceeding 6 miles, covering an area of approximately 12 miles. The volume of magma involved in this single intrusion event would fill 200,000 Olympic-sized swimming pools. The magma did not reach the surface. This time, physical evidence confirmed the connection between both systems. During the crisis, instruments recorded the seafloor directly above Kolumbo, sinking by 13 inches. Simultaneously, the surface of Santorini rose by more than 4 inches. The interpretation was unmistakable. Magma was redistributing between the two volcanic systems in real time, pressure releasing from one location while building in another. Scientists described it as if both volcanoes were breathing together, sharing the same underground heartbeat. This discovery transforms every risk calculation for the region. Emergency planners can no longer treat Kolumbo and Santorini as isolated threats. Activity in one system directly affects the other. 2 volcanoes, 1 shared reservoir, and 3.5 million tourists visiting the danger zone every year. Kolumbo is not the only hidden danger lurking beneath Mediterranean waters. Approximately 109 miles south of Naples, Italy, another submarine volcano sits in the Tyrrhenian Sea. Its name is Marsili, and almost nobody has heard of it. The scale of Marsili defies expectations. This underwater giant stretches approximately 43 miles long and 19 miles wide. That makes it larger than Mount Etna, the most famous volcano in Europe. Marsili rises nearly 10,000 feet from the seafloor. Its peak sits just 1,500 feet below the surface, a massive volcanic structure hiding in plain sight beneath busy shipping lanes. Scientists call it the most underestimated volcano on the European continent. The Italian National Institute of Geophysics and Volcanology has issued stark warnings about its condition. Marsili has fragile walls composed of unstable rocks. A shallow magma chamber feeds the system from below. The combination creates a structure vulnerable to sudden catastrophic failure. Researchers at the University of Bologna ran simulations modeling what happens if Marsili experiences partial flank collapse. The results were alarming. Tsunami waves would reach the Aeolian Islands in approximately 10 minutes. The coasts of Calabria and Sicily would see impact within 20 minutes. In the most extreme scenarios, waves reaching 66 feet could strike populated coastlines. The Mediterranean faces a critical vulnerability that the Pacific does not share. There is no robust tsunami warning system covering these waters. The distances between submarine volcanoes and populated coasts are simply too short. Reaction time is measured in minutes, not hours. By the time warnings reach coastal communities, the waves may already be visible on the horizon. The pattern emerges with disturbing clarity. Hidden submarine volcanoes scattered across the Mediterranean. Densely populated coastlines within immediate striking distance. Inadequate warning infrastructure to provide meaningful evacuation time.
Millions of people live, work, and vacation in coastal zones that a volcanic tsunami could strike with little warning. Kolumbo volcano threatens Santorini, while other hidden Mediterranean volcanoes endanger nearby coasts. Scientists now recognize these are not isolated hazards, but parts of a broader volcanic system beneath the sea. Monitoring efforts have intensified rapidly since the 2025 crisis. In December 2025, the research vessel RV Meteor launched a Santorini expedition equipped with advanced underwater sensors designed to detect magma movement in real time. These systems aim to identify warning signs weeks or even months before surface activity appears. Continuous observation has been underway for years. Seismographs record every tremor. Pressure sensors track changes along the seafloor. Satellite measurements monitor subtle shifts across the caldera. During the earthquake swarm, new instruments were installed directly inside Kolumbo's crater, 1,600 feet below the surface, streaming data that scientists could not access just a few years ago. International cooperation has expanded as Greek, Italian, and British researchers share seismic and geological data. A major eruption would not respect borders. It could disrupt shipping routes, aviation corridors, and coastlines across multiple nations. Despite progress, one reality remains unchanged. The magma chamber beneath Kolumbo continues to grow, adding roughly 141 million cubic feet of molten rock each year. The system linking Kolumbo and Santorini adds further uncertainty, with pressure changes in one volcano capable of affecting the other within days. Tourists will keep returning to Santorini's white cliffs and famous sunsets. Life continues on the surface. But 4 miles offshore and deep beneath the sea, magma continues to rise. The chamber continues to expand. And the geological countdown that began centuries ago moves steadily forward.